Hello everyone, welcome back. In previous video, we talked about the remainder theorem, and as we know, when the polynomial is divided by a linear binomial like x minus a, then the remainder is f of a. It's very straightforward, and it happened to be like this. Without using synthetic division, we can just easily substitute the value to find out the answer, and this answer is a remainder. But what is actually this theorem telling us, and how can we use this in a different situation? We are going to use another theorem to answer this question. So let's check another example. We have, this is a polynomial with degree of 2, which has a quadratic function, so we are going to use the synthetic division to try again. So it's 1, negative 2, and the outside part is 2 because we just reverse the value here. And we copy down 1, so 1 times 2 is 2, we add them is 1. Then 1 times 2 is 2, we add them is 0. So remainder is 0, so we can just write down the answer as x plus 1. Since remainder is 0, we don't need to write down like this, no need. Okay, so we can just leave it like that. So very similar to the previous example, I can also rewrite this one as x squared minus x minus 2 equals x minus 2 times, because this is a quotient, x plus 1. So some students already make a connection, already notice, oh, this is like the factoring we did before, right? So in this example, we actually use division to look at the factoring in a different perspective. So this time we are going to do some similar example. I'm going to replace x as 2 in this one, and some students probably already guessed that. The final answer will be 0, because as we mentioned in remainder theorem, the remainder is always the value of this, because the g of x divided by x minus 2, so g of 2 will be the remainder. That's what remainder telling us. But we are going to look at this example in a different way. So just like, for example, if I have number 15, let's say that, and divided by 3, we know the answer is 5 and remainder is 0. So in another word, we call 3 and 5 are factors of 15 because they are divisible. Remainder is 0, so that's why we call the factor of 15. So we are going to extend this idea into polynomial. When we factor this one as this, these two are called factors. So when can we determine, or when can we say they are factors? When the remainder is 0. So this fact is called factor theorem. So factor theorem telling us if a polynomial f of x is divided by x minus a and the remainder is 0, then the x minus a is called the factor of f of x. And the fact of this is vice versa, which means if x minus a is a factor of x, then we can say f of a is 0. So if this one is a fact, then f of a is 0, meaning the remainder is 0. So it's the reason we have this fact, because we can easily to use this theorem to help us to check do we have a factor or not. So this will help us to easily to determine the solution of the equation. So if the remainder is 0, we know it's a factor, so we can use them to solve the equation. And it's very easy and very applicable when we solve polynomial equations. Okay, so that's two theorems we talk about today. One is remainder theorem. This is how we use the value here to find the remainder. And the other one, we can use that remainder to tell us, do we have a factor or not? And then we can easily use this result to solve the possible polynomial equation in the future. Okay, so that's how it works. Okay, in next video, we are going to see more examples to help us to apply these theorems in the different questions so you have better understanding of these problems. Okay, see you soon, everyone.